You have been at the forefront of tech and innovation for years and years. After building MongoDB into a billion-dollar company, Eliot Horowitz is back with a $45 million vision for AI automation.
Yeah, no, that's one of the things I love about what we're doing here is that the things we're building and we're working on are things you can actually touch and see and interact with.
So we're going to start with the furthest cup and then make our way home.
This is wild. I need this in my house.
If you ask any software engineer to go, who's maybe done it before, but maybe not, like to go build a mobile application or to use a new database, they're like, fine. They can learn it in like 3 days. And then you say, okay, now go make a motor respond to light. They're like, what? What I think is really important that we're doing is bridging the gap between the hardware engineers, the electrical engineers, and the software engineers, right? There's 30 million software engineers in the world. And I think most of them, if you ask them to go work on hardware products, are gonna kind of look at you funny and be like, no, thank you. And one of my main goals is I want those 30 million software engineers to be like, okay, I not only could work on a hardware project, but I'm excited to.
Hi, Eliot. How are you today?
I'm good, Tiffany. Thanks for coming.
Thanks for having me. We did a brief tour already of the office, and just seeing what you are up to is, it's one thing to read about it, but to start to see it in action is really exciting.
Yeah, no, that's one of the things I love about what we're doing here is that the things we're building and we're working on are things you can actually touch and see and interact with.
Yes, 100%. Eliot, I'm really curious to get your take. You have been at the forefront of tech and innovation for years and years. I know you co-founded MongoDB, so you were in the space of databases for a long time, and now transitioned into or shifted into Viam, which focuses on real-world applications or solving real-world problems through AI applications. What was that shift like?
Yeah, it's a great question, right? Obviously, I was at MongoDB for 13 years and had a great time there. And when I left MongoDB and wasn't really sure what I was doing, and it also happened to be during COVID, I started doing what I do a lot. It was just start tinkering with things around my house. Didn't have much else to do. And so I was trying to automate things and make sprinklers work better and all these things work better. And I would say throughout my engineering life, I've always sort of once in a while gone back to, okay, how do I make software and hardware work together? And after a couple of months of sort of tinkering, it was very clear to me that I really liked working with actual physical devices, that a lot of people want physical devices to do more and to be better, and that the tools available to engineers weren't as good as they could be. And so we're like, great, let's go see if we can solve that problem to make it easier for software engineers and hardware engineers to work together to to bring great products to life.
I know your background is in engineering. Was it primarily up until that point when you mentioned during the pandemic, you started tinkering with some hardware? Was it primarily up until that point software, and then this was kind of the introduction to hardware, or?
So professionally, entirely software.
Yes.
In college, even in high school, I definitely played with hardware a little bit. In college, I did some robotics. And took a robotics class and did a little research on robotics, but very minimal. Yeah. After college, every 5 years or so, I'd buy some stuff and start tinkering with it. And it was always a bit frustrating to sort of make real progress, and so it always just kind of fell into the bin of things in the closet. And it wasn't until after I left MongoDB and had a little bit more concerted time where I could actually make real progress. And then look, I'm a big believer in learning by doing. And so what I actually ended up doing, and a bit of a lucky situation, is where I could actually go hire some people who were experts more on the hardware side, more on the electrical side, who would come in and work with me and learning by osmosis. Wasn't learning from just sitting in a room with a book, but I actually had people working with me and we would work on projects together. And that was how I really got into it.
I feel like I can relate to your curiosity when you first started kind of tinkering more, with hardware, continuing to tinker more as a developer myself. It's one of those things where software seems so, nowadays it seems so attainable. It's, there's so much documentation online. It seems so great to start building and whatnot. I've always been curious about robotics and hardware, but it seems like this whole other world that is usually separated, it feels like, but it's not.
Yeah, no, if you ask any software engineer to go, who's, maybe done it before, but maybe not, like to go build a mobile application or to use a new database, they're like, fine. Yes. They can learn it in like 3 days. And then you say, okay, now go make a motor respond to light. They're like, what? You ask them to go work on a company building the next generation of automatic coffee machine. They're gonna be like, I can build the web app or like the database for that, but like building, like actually integrating with the hardware, that feels like a different skill set. But at the end of the day, it's actually, in my opinion, not that different, right? there's mechanical engineering and electrical engineering. Those are obviously very important skill sets, and that's a whole separate field. But what I think is really important that we're doing is bridging the gap between the hardware engineers, the electrical engineers, and the software engineers. Right? There's 30 million software engineers in the world, and I think most of them, if you ask them to go work on hardware products, are gonna kind of look at you funny and be like, no, thank you. And one of my main goals is I want those 30 million software engineers to be like, okay, I not only could work on a hardware project, but I'm excited to because I live in the physical world and I would like things in my space, my home, my office, my outdoor environment to be better and to be smarter.
100%. And going back to when you the early days when you first started Viam, what was Viam's core mission and how has that evolved to today?
Yeah. So we spent about a year just building things. I built a chess playing robot. I built robots for my house. I built a better sprinkler system. Just built things and hired a few people and we did it together. And then about a year later, we were like, okay, we need to build a platform to make this work. The biggest thing we sort of learned along the way, sort of after that moment, was can be pretty academic at times in sort of my thinking. And I was like, okay, great. Everything we're doing is robotics because it's all about taking sensors and things that move and motors and maybe AI and putting them together to make things happen in the real world. And that feels like robotics to me. It turns out that when you think about robotics and robots, most people think more robot-y things, whether it's robot dogs or humanoid robots. And we have a much sort of broader mandate. And so we've stopped using the word robot so much. Yeah. But we really think that everything that lives in the real world and takes in data from the real world, whether it's cameras or a temperature sensor or a humidity sensor, and that does something, whether it's turning on a light or turning a motor on or moving around and doing something, it doesn't matter. And it's probably going to use some AI and some cloud computing. That's where we can help.
And speaking of helping, we're going to get to developers later on, but I'm curious to hear, can you share some examples of recent that Viam has worked with other companies, some success stories?
Yeah, so one of my favorites, and I love boats and fishing, is in the marine space. We have a client called Canyon Runner. And Canyon Runner had a few hundred clients, all with boats, and they would help people figure out how to run their boats, where to go, how to avoid bad weather, where to go fishing, sort of all these things to help people manage their boating life. Yeah. And it was completely manual. Right, they would just be on the phone 24/7, basically talking to people. And so what we did is we helped them develop a product that went onto the boats. And so then they had real-time information on everything happening. They have a map, they can see what's happening. Their clients can actually opt in so they can see each other, so they can communicate with each other, and in real time know what's going on. So they can say, okay, I know where the fish are and you need to go 5 miles north. Or hey, they can put a geofence around someone saying, you're getting close to lightning, or there's an emergency there's a sudden lightning storm coming towards you. You need to get out of the way, right? Things like that. So that's a really big one. Another client we're really excited about is UBS Arena. Mm-hmm. And if you think about Arena, there's so many things you could do there, from having it run more efficiently in terms of HVACs and lighting and helping with parking and all sorts of things. But when we were working with them and with the owners of the arena and the owners of the New York Islanders, one of the things that they care the most about is fan experience. Right? When people come to the arena, they want them to have the best possible time. And that makes sense from a business standpoint and just from a fan standpoint. So the first project we're tackling is actually, we'll be launching an app in a few weeks where on the Islanders app on the phone, you'll be able to see the wait time at all the bathrooms in the arena. With the basic idea, you're sitting in your seat, you want to know if it's a good time to take your kids to the bathroom, it'll just tell you, yes, now's a good time, now's a bad time. Over time, it'll be able to tell you the same things about the concession stands. And then what I really want to get to the point is where you can look at your phone and be like, okay, cool, I need to take my kids to the bathroom, and they need a hot dog and they want cotton candy. What's the best way to do that? And what's the best time to do that? Right, because that's the reality of it's of that kind of life. It's not about okay, wait 1 minute or 3 minutes, but when your 5-year-old needs to go to the bathroom and needs cotton candy on the way back, the arena already has security cameras all over the arena, and so we have just tapped into those feeds and are looking at the lines outside of the bathrooms. No new cameras, no new hardware. It's just pretty straightforward computer vision and machine learning, building models that look at those camera feeds. Then we'll be able to tie it into the cameras looking at the concession stands, and then tie it into the point of sale systems for the concession stands to get real-time inventory information, and then so on and so forth.
That's really cool. I like both of those examples because the first one you mentioned is, it sounds like Viam more so came in there and created new software, new technology, if you will. Going back to our conversation around how especially around software developers, how, it's more so build me an app. Okay, great. But anything with hardware related, it's kind of like, ooh, I don't know. I feel like, and I'm curious to get your take on this too, I've seen this kind of shift or transition to where both of those worlds are really merging. I mean, of course, you need software for hardware and vice versa, but seeing a lot more interesting kind of hardware or AI and automation, different things like that coming up. For any developers who are watching this and say they are focused currently on building, what we think of when we think of apps or websites,
Yep.
What is some advice for someone who wants to transition more into that space?
So I would say for me, it's a combination of sort of skills and then sort of the why. And so for me, it's very simple. It's like and I tell everyone who starts at Viam, every engineer to do this, which is find something in their lives that they wish there was more automation for. Whether it's a automatic cat food feeder or a better light management system or a plant watering device. There's almost every engineer has something in their house that is physical that they wish was smarter.
Yeah, 100%.
Right, and what I've told people is it's probably easier, especially with our stack, to actually start making it smarter than you realize. And so just try. And when you do that, right, then you actually are seeing, okay, I actually can do things in the real world. I can make things happen based on whatever the inputs are. And then you sort of get the idea that, okay, well, once I can do that, I can do almost anything. Because the biggest problem engineers have, in my experience, starting is the idea that they've got to get data from the real world, do something with that data, connect that to the cloud in some way for management, debugging, write software that does something with that information, and then makes that something happen in the real world. And whether you have one sensor or 100 sensors or one motor or 100 motors, for software engineers, that's not the hard part, right? They know how to think about those kinds of things. And there are software engineers who really understand control systems out there. Lots of great research over the last 50 plus years on that. The hard part is connecting all the dots. Once you connect the dots in one simple example, figuring out how to extrapolate is actually not that hard for most engineers.
That's true, how to scale more so. It's just that initial connecting the dots.
It's the whole process of like taking like a real-time sensor value, using AI on that sensor value, connecting it to the cloud, deploying new versions of software, how to iterate quickly, how to actually make motors turn. And so one of my favorite examples is one that I demo all the time, and everyone laughs at me for it being so simple, is this very simple cat food feeder I built for my cats. And it's very simple, but it has a camera that's looking at their food dish and using AI to figure out if the bowl's empty or not, and then we'll feed the cats automatically, and I can look at it remotely, and I can deploy new software remotely, and it turns the motor, and it's all and it can learn which cat's eating and how much they're eating, and it can learn all that. And at the end of the day, it's a pretty simple product.
Yeah.
It's a pretty simple use, but it shows you sort of, okay, look, I can do all these things. I can connect all the dots. And now it's great. If I have one camera or 1,000 cameras at an arena or one motor or 15 different motors to drive a car, it's the same stuff.
Exactly. You really honestly inspired me. I've always wanted to tinker with that. I never have, but I'm going to email you in a few weeks and let you know what I built. I don't have cats, but I have dogs, so maybe I can do something with that.
Same thing, right? Like dog playing robots. There's a million things you can do with dogs.
There's so many different things.
And that's exactly what we want. And we want to get more people, and I actually encourage people just to like email me and like ask questions.
Yeah.
Like these things are a little esoteric sometimes, and we're trying to make them less esoteric. Yes. But it's a big space, and I think that's the fun part is like, okay, well, we can actually make things happen.
The things, I'm not going to say problems, but problems that you can solve is when you start thinking about that with AI and automation is endless.
Yeah, and I think the other thing that I want people to really understand is that, yes, there's a world in which you've got like perfect AI and perfect humanoid machines, and you could maybe do really cool things then, but I don't know if that's 5 years away or 50 years away. Yeah. And there's no need to wait, right? There are so many things that people can build today that actually will improve things like very quickly and actually make real progress very quickly. And that's the cool part, is you can actually do things and accomplish them. My cat food feeder, when I built it, my son was 11, and we did it in an afternoon. Right, this wasn't like a 3-week project. This was we bought one, we took it apart, we replaced all the electronics with stuff we bought off Amazon for $40. Yeah. And a few hours later, we had the basic version working. Right, it wasn't a super complicated thing. It was just straightforward.
It doesn't have to be super complicated.
It's better if it's not.
Yeah, I like
right?
that.
Engineers tend to think they have to make things very complicated, and in reality, starting simple is almost always the better option.
It is. I love that. I think we all need that reminder more often than not.
No, I mean, even me, like I always like, okay, but I can have this feature and that feature and this feature, and then like, do I really need any of them?
I know.
Probably not.
Start with the basics and then build upon it.
And then you'll see, right? I'm a big believer in if you start with the basics, you'll actually know what matters after that. Because you never know until you actually can feel it.
It's true. And I find sometimes starting with the basics is the best way to actually reinforce learnings. I'm not, otherwise if I try and add in too many features for anything I'm building, even talking about software, it's just the learnings can get a little bit lost and you're just coding a bunch of stuff or whatnot, putting together a bunch of stuff.
No, exactly. And that's, again, why I like the cat food feeder demo. It's an end-to-end prototype.
Continuing to look ahead, but focusing on Viam now, I'm sure there are tons of projects that you can't share with us, but what are some that you can, looking ahead a little bit about for them?
Yeah, one of the areas we're doing a lot of work on is food tech. So we talked about dishwashing, but we're also working with a number of clients on improving the quality of their food displays. So how many times have people been in an airport? They're walking by a bunch of restaurants with food out, and you tend to go to the ones where the food looks better. How do we automatically make that happen? And the restaurants know that they will sell more food if the food looks better. People think it's fresher, and it actually is fresher, and how do we make that better? And build systems like that. That's a fun area. How do we make food more real time, right? So less earlier prepared food and be able to respond more in real time. We've got a number of clients working on what I'm gonna call the next generation of food vending machines, where instead of just sort of stuff in plastic, it's actually fresh food made in a more automated way using automation so that when you're in an airport, you're eating better, right? Because right now you're getting stuff that's pre-made and not great, and can we make it fresh?
Exactly.
Yeah, that's a big one. I'm a big fan of anything that shortens supply chains, that improves what you're eating, how you're living, things like that.
Eliot, thank you so much for your time. I know I'm leaving this conversation feeling very inspired, and I'm ready to start building. So thank you so much again.
Yeah, no, thanks for coming. And I love the idea of building projects with people. One of the things I did a lot early in MongoDB was help people build stuff. And that was some of the, personally, that was one of my favorite things to do. And I love doing the same thing here. So as I said before, we're doing a lot of stuff in food tech. And so one of the things we have done as sort of a demo that's now turning into a product in some cases is this wine pouring robot that will just, take a bottle of wine, or in this case, water, and start pouring it for you.
What?
So so we can actually go and give it a try.
So now we're pre-planning all the movements.
Okay.
Now we're going to execute them.
It's so smooth. Oh my goodness. That's wild.
So one of my favorite things about this is when they first built it and said it was working, I came over, I looked at it, and it spilled a little bit. And I was like, let's make it not spill. And the team was like, well, when I pour wine, I always spill a little bit. And I'm like, all right, well, first you need to drink more wine. And two, let's practice. And then so about 2 days later, it looked like this, and it's now it spills nothing.
How does it detect the cup? Is the cup placed where it knows that the robot will pour to, or does the robot identifying?
So this camera over here identifies the cups. It does a simple circle detection algorithm, and then from there it's translated from camera space into the space of the arm.
That's wild. So could it do, for example, 2 cups?
Yeah, 100%. So let's try that out.
Okay, let's see.
So I'm just gonna roll over and just press this button again.
Okay.
So we're pre-planning all the motions again.
And pre-planning is really the camera is that also including the camera sensing where the cups are?
Yeah.
Okay.
So we're going to start with the furthest cup and then make our way home.
This is wild. I need this in my house.
So it's avoiding the second cup to make sure that it doesn't get knocked over.
Yeah. Wow. It's so smooth. It's just... That's wild. That's so cool.
And it's actually sitting on a scale. So that we know how much is left in the bottle, so we know how much to pour.
Oh my goodness.
And how aggressively to tilt the bottle to pour the right amount.
So what would it be? So for example, right now we have 2 larger cups. Say we had 2 standard wine glasses. Would it take that into the size of the cup into account for how much it pours as well?
It could. I mean,
it could.
You can imagine the pieces, right? You can have an ML model that says, hey, looking at these kind of cups, how much wine should you pour?
Yeah, exactly.
Things like that. And this is sort of the whole iteration thing we were talking about. Is start simple, and then you want to tell different kinds of wine glasses, or get smarter about, okay, how do I pour red wine versus white wine or champagne? And champagne I've got to go slower on. Once you have the basics, and you can actually let software engineers start playing with those basics, then you can actually move very quickly to make it sort of cooler and cooler and make it more real world.
Exactly.
And what I really want is one of these at home that just like keeps wine glasses filled all the time on the table. You're having dinner, it just fills up, it just keeps going with water. You don't have to like pass water around. It's just like great. It just keeps everything filled.
Yeah. That's
so
amazing.
one day someone will build me a cool dining room table with an arm coming out of the middle.
Exactly.
That does this.
Oh my goodness, yeah, that will be, in the future, that will be just, what all dining room tables have, I hope anyways. So now for you, when you're building it, you just got to convince Eliot to let you test out with different like red wine, white wine, champagne.
Yeah, exactly. I'm looking forward to that.
Yeah, exactly.
So for right now it's sparkling cider with water in it.
Yeah,
So we're keeping it work appropriate.
Exactly. Wow, that's fascinating. That's incredible. Thank you so much for showing
of course.
us.
Thank you so much.
Wow.